Okay, so this lesson is 2-1 for Algebra 2 Honors. We're covering graphing two variable equations. The learning targets are write equations in two variables and represent relationships between quantities, and graph equations on coordinate axes with labels and scales. So let's get started. So the scenario here. Um, so Roy recently won a trivia contest, and great for Roy. The prize was a 5-day trip to New York City, including a round-trip airplane ticket to and $3,000 in cash. So yeah, he's basically getting the airplane ticket for free for 5 days. Basically means he's got to leave after 5 days, right? They've already got the tickets, and he's getting $3,000 in cash. Uh, the money, the $3,000, will pay the cost of hotel rooms, meals, entertainment, and incidentals. So to prepare for his trip, Roy gathered the following information. So he figured out that a hotel room in New York City costs $310 per night, and the trip includes staying 5 nights. And it's kind of interesting the way that they put it. Again, he's getting the round trip airplane ticket, but the money, the cost for the hotel is going to have to come out of the $3,000. Okay. Um, anyway, the other cost here would be a taxi between New York City and LaGuardia Airport, and that'll cost 45 bucks each way. All right, so he will have to pay for the hotel and the taxi, and it's going to come out of that $3,000 in cash. All right. So Roy must set aside the cash required to pay for his hotel room and for a taxi service to and from the airport. Once he has done this, Roy can begin to make plans to enjoy the city with his remaining prize funds. So I guess the real big question is how much does he have left, right? He won $3,000, but he's going to have to pay for those basic expenses. So number one is asking just that. How much money will Roy have available to spend on performances, meals, and any other expenses that might arise after paying for his hotel and taxis? Okay. To show the work here, basically, he's got $3,000 to start with. And we're going to subtract off. He went ahead and saw that or figured out that the hotel was $310 per night, so 310, and he's staying for 5 nights, so 310 times 5 minus the taxi, right? And that's going to be 45 bucks each way, so he's going to have to take that twice. And so we'll go ahead and calculate that real quick here. Let me bring up my calculator. Unfortunately, you guys can't see this. It's not installed yet, but we'll go ahead and calculate it. So 3,000 minus 310 times 5 minus 45 times 2 is $1,360. So after he pays for the hotel and the taxi, he's going to have $1,360 to spend on whatever he wants in New York City during his 5-day trip. Not bad, right? That's a pretty good chunk of change. Okay. So during his trip to New York City, Roy wants to spend only his winnings from the contest, none of his own money there. So basically, he's got the 1360 left here to spend. He wants to focus on two of his favorite pastimes, which is attending theater or musical performances and dining in restaurants. Okay, so they're trying to make it simple for us, right? Either we're going to a performance or we're going to eat, and that's pretty much all we're gonna talk about during this example. So after surfing the web, Roy determines the following facts. On average, a ticket for a performance in New York costs 100 bucks, and he will spend an average of $40 per meal eating. Okay, so let's go ahead and use that information. All right, so number two, we're going to model with that information. So we're going to basically, there's a trend with Springboard, so we're going to fill out a table, recognize a pattern, and then try to come up with some kind of mathematical function or equation that represents that pattern. So Roy wants to know how the purchase of each ticket affects his available money. Fill in the table below and plot the points on the grid. All right, so again, the one I guess I could probably write over here. This one is performance, right? So they don't really, so again, not really clear here. Um, they want to know the purchase of each ticket. So really, we're just talking about performances here. They could have been a little bit more clear on that. Performances only. We do not care about meals at this point in time. M stands for money, not meals. T stands for tickets. And one performance, one ticket, one ticket is going to be about, on average, right, $100. All right, so let's go ahead and use that information. So he's got $1,360. If he buys no tickets for any performances, then he still has $1,360. If he buys one ticket, well, that's $1,360 minus $100 because he bought one ticket, so that would be $1,260. If he buys two tickets, well, that's just another $100. 1,160. So we're just basically, we can already see the trend here. We're going down by $100 every single time. $1,060, $960, $860, and be careful here. It doesn't go to 6, it goes to 8. So now we're going to have to kind of be clever here if we don't want to come up with the equation yet, which we're not going to yet, or the function, I should say. But what we're going to do here is we're just going to notice the trend and apply it in a calculation. So this essentially is 1360 minus, and again, 0 was just 100 times 0. The 1 was minus $100, minus $200 for 2, minus $300 for 3, minus $400, minus $500. So we can assume that this is going to be minus $800. Did I screw this up? We got 1360, 1260. Yep, looks good. Okay. So in this case, it's minus $800. So we have 1360 minus $800 will be $560. Okay. Let's see here. 10 would be minus $1,000. So 1360 minus $1,000 would be $360. And 13 again would be $1,300 total. 13 times 100, and so we'd only have $60 left at that point in time. All right, so let's go ahead and graph this. Okay, so first one here, we have number of tickets, which is T in this case. You can see the T here on the x-axis, the M on the y-axis. So you can think of these as ordered points, and or ordered pairs, and we're just going to go ahead and graph these. So we have T is 0, and money would be 1360. So this is going by 100s, 100, 200, 300, 400. So this would be 1200, 1300, and 1360 should be, I don't know, right around there, let's say. And if we bought one ticket, it's going to be 1260. So let's just say there's 1200. We'll just say right around there. 3 would be 1160, 1060, 960, and 860 for 5. You can see I'm kind of just following the pattern and just making sure that here we got 5, 860. 8 would be 560, so let's go to 8. 8 and then up to 560 here. And 10 would be 360. And finally 13 would be $60. And they've put a little mark here, and that's where 13 is, and we have about $60 here. Okay, so what are the patterns that we notice? Well, first of all, it's linear, right? So we'll say linear, and we'll just say which is constant rate of change. Constant rate of change. Okay. Go ahead and save that for a second. Just wait for it to save. All right, so explain how you determine the values for 8, 10, and 13 tickets. Well, what did we do? We took the original, so we took 100 times the number of tickets from the spending cash, right, of $1,360. All right, and then finally, the moment we've all been waiting for, we are going to write a function, m of t, that represents the amount of money that Roy has left after purchasing t tickets. So we pretty much explored this in all kinds of different ways here, and so let's go ahead and write our function. So we have m of t is equal to, and this can be written in a few different ways. You could either write it like this, 1360, which is our original cash, minus 100 times the number of tickets, right? Every time we're subtracting off 100 for $100. Or some of you may prefer to write it like this, going straight to slope-intercept form. You guys can kind of see what's coming, many of you, which you would say negative 100t plus 1360. And these are the exact same thing. We're just flipping around the 1360 and the negative 100t. All right. All right, let's continue on. So use mathematical terminology to explain what the negative 100 and 1360 each represent in your function. So negative 100 is the rate of change, or slope, rate of change. And I'll just put in parentheses slope. And 1360 is starting value. Or cash starting value. All right. And I guess I could add in here, negative 100 is the price per ticket. We could do that, but I think they may ask that later on. I'm not really sure. Anyway, number 7. So Roy wonders how much his meal costs. So we talked all about we analyzed completely the performance tickets and came up with the function, everything like that. Now, I'm assuming we're going to go ahead and talk about the meal cost, right? Do the exact same thing. So Roy wonders how much his meal cost will affect his spending money. So we're going to write a function, d of m, that represents the amount of money Roy has left after purchasing m number of meals. So we're calling the function something else, but we're essentially skipping all of that table stuff. So they're expecting you to kind of be able to think like, yeah, we are doing the same thing. Do I really need to write all that down? No, I kind of, get the hint here, and so we can go straight to it. So, anyway, in this case, how much does a meal cost? Well, a meal is approximately $40. So every time we buy a meal, we're going to subtract $40. And we have our initial starting value of $1,360. All right, or again, and that would be like slope-intercept form. You could have done it like this. Like I said before, same exact thing. How much did we start with? 1360 minus 40m. These are equivalent. All right, so now we're going to go ahead and graph this function. And the way that I am going to graph it is I'm going to find the intercepts, actually. I don't want to write like a million different points here. I know this line is going to, or at least I have an idea of where this line is going to be. It's got a negative slope. It's going to start way up here and go down. I really don't want to have to like do a point and then point and then point. I really just want 2 points, right? Just the intercept there and the intercept here, and then you can connect them and you're all done. So the other way is fine. You can do it that way if you want, but I find that this is a little bit quicker. So in this case, we have m and d of m, and I'm just going to call these the x and y intercept, especially because they didn't really label. I mean, they labeled this as the function, but but whatever. So I'm going to say x intercept is equal to, and y intercept is equal to. And remember, these are points. And so anyway, how do you okay, so for each of these, right, this is y is equal to well, I guess I'm just going to do one of these. Y is equal to negative 40x plus 1360, and we can do what's called the cover-up method, and we call it the cover-up method because you're you're plugging in 0 for y-intercepts, and so let me put in my little parentheses here, and then it essentially cancels out one of the terms. So we kind of just cover it up and pretend like it's not there because it is canceled out. So anyway, for the x-intercept, we know that the y is going to be 0, and for the y-intercept, the x is going to be 0. So let's go ahead and solve for each of these. So for the x-intercept, if y was 0, right here, this guy right here was 0, then that would be 0 is equal to negative 40m plus 1360. So we would subtract 1360 over to get negative 1360 is equal to negative 40m, and then divide by negative 40 to get m. So in this case, let me pop that in my calculator here, negative 1360 divided by negative 40, and that will get you 34. And the y-intercept, we're going to do the exact same thing here. The x is going to be 0, so this negative 40 times 0 or times m will cancel out, and as you just get y is equal to 1360. You'll see that that's actually probably the quickest way to graph these lines, just finding the x and y intercept. Again, I understand that these are not technically x and y axes. This is m and d of m, but you know, we're just putting it in terms that we're used to and we understand. So anyway, so let's go ahead and graph these. So or plot these. So we've got 34, 0. So these are going by 5s, it looks like. So here is approximately 34, 0. And the next one would be 0, 1360. So that would be about right here. And then we're going to put a line through this. Let me use my, well, I guess I could draw it. Or attempt to draw it. Okay, just like that. Not the straightest line in the world, but not bad. All right, so what kind of function is d of m? Well, again, we have a linear function. It is a line, constant rate of change, and they're asking what is the rate of change, including the units. So the rate of change, well, how much are we going down for every meal? Well, that is negative $40. We'll say negative $40. Let's do it like this. There's a few different ways to write this, but I'm going to say negative $40 per meal. Or, I guess let's write it the other way. Negative $40 per meal. That would be equivalent. Boom or boom. Okay. This does not look like it says the word meal, but that's okay. Autocorrect. All right, let me save that before we continue because it's starting to bug out on me a little bit. All right, make sense of problems. So are all values for m on your graph valid in this situation, given that m represents the number of meals that Roy can buy? I would say no, because let's see here. There are a few different reasons. No, you can't have negative meals for one. If I look up here, right, this technically would go, I mean, it's a line, it goes on forever. We haven't really listed any constraints. But anyway, you couldn't have negative meals, right? No, can't have negative meals. Negative meals. And let's see, what else? We also can't have, also can't have fractions of meals. I know in real life you technically could potentially buy half a meal or something like that, but they don't state that that's an option here. So right now we're just talking about full meals, all right? And of course you couldn't have a negative meal. All right, so that concludes lesson, which lesson are we on here? Lesson 2-1, which is graphing two variable equations.